December 1932. A young Polish mathematician named Marian Rejewski sits alone in a Warsaw office, staring at encrypted German messages that look like random gibberish. His supervisor has given him a seemingly impossible task: figure out the wirings of a machine he's never even seen. The machine is called Enigma, and what Rejewski is about to accomplish will become the foundation for one of the greatest intelligence victories in history. Fast forward to 1939. War is exploding across Europe. Nazi Germany's military communications are protected by an updated, more complex version of that same Enigma machine, generating 159 quintillion possible settings. The British have captured the machines. They know how they work, and they're still utterly lost. But here's what the Germans don't know. 7 years earlier, 3 Polish mathematicians had already cracked the original Enigma. And in July 1939, just weeks before Hitler's invasion of Poland, those mathematicians handed everything they'd learned to the British and French. Blueprints, techniques, and even replica machines they'd built themselves. This is Chishel, and today we're telling you the real story of how Enigma was broken. Not by one genius, but by a relay race of brilliant minds across 2 countries, working with nothing but mathematics, ingenuity, and courage. Before we meet the British codebreakers, we need to understand what they inherited from the Poles. The Enigma machine looks deceptively simple, like a typewriter married to an electrical circuit. Press a key, and an electrical signal travels through a maze of rotating wheels called rotors, bounces off a reflector, and comes back through the rotors again, lighting up a completely different letter. Press A, and maybe K lights up. Press A again immediately after, and now R lights up. The rotors rotate after every keystroke, constantly changing the maze. But the real complexity comes from something called the plug board, a patch panel at the front that adds another layer of letter swapping before the signal even reaches the rotors. With 3 rotors chosen from a set of 5, placed in any order, set to any starting position, plus 10 plug board connections, you get 159 quintillion possible configurations. The Poles first encountered Enigma in 1928. By the end of 1932, working at Poland's Cipher Bureau, 3 young mathematicians had done what seemed impossible. Marian Rejewski was 27 years old. Alongside Jerzy Różycki and Henryk Zagalski, he'd been recruited because the head of Poland's cryptography section believed the key to breaking codes lay in mathematics, not linguistics. And they had a secret weapon. French intelligence had recruited a German spy named Hans Thilo Schmidt, who provided Enigma instruction manuals and the daily settings for September and October 1932. But here's the remarkable part: even with those manuals, the French couldn't break Enigma. Neither could the British. Rejewski could. He approached it like a pure math problem, using permutation theory and group theory abstract mathematical concepts that had never been applied to cryptography before. By December 1932, working with those French-supplied materials, Rejewski determined the internal wiring of Enigma's rotors, something he'd accomplished without ever seeing the actual military version of the machine. Think about that. He reverse-engineered a device he couldn't touch, using only encrypted messages and mathematical reasoning. For the next 7 years, the 3 Polish mathematicians stayed ahead of German improvements to Enigma. When the Germans started changing settings monthly instead of quarterly, the Poles adapted. Rejewski invented the cyclometer, a device that cataloged the characteristics of all 105,456 possible rotor settings. It took them a year to complete the catalog. Then the Germans changed the reflector. The catalog became useless, so they built it again. In 1938, the Germans added 2 more rotors to the set, increasing the possible wheel combinations. The Poles couldn't manually process all the new possibilities. So they built a machine. They called it the Bombe, the bomb, not because it exploded, but possibly after the ice cream dessert one of them was eating when they had the breakthrough. The Bombe was a mechanical device that could test multiple rotor settings simultaneously by looking for logical contradictions in the encrypted text. Working with engineers at AVA Radio Manufacturing Company in Warsaw, they built 6 of these machines. By 1938, the Polish team was decrypting 75% of all German Enigma messages. But Poland was running out of time. In July 1939, German troops were massing at the border. Using their replica Enigmas, the Poles were decoding 95% of German radio transmissions, and those transmissions made invasion unmistakably clear. So, they did something extraordinary. In late July 1939, just weeks before World War II began, the Polish Cipher Bureau invited British and French cryptographers to a secret meeting outside Warsaw, where they revealed everything: how they'd broken Enigma, the rotor wirings, their techniques, Zygalski's sheets, and even gave them replica Enigma machines. The British were astonished. They'd been working on Enigma for years, with essentially no progress. The Poles filled this huge hole in British knowledge and provided the groundwork on which Bletchley Park codebreakers built their efforts. 5 weeks later, Hitler invaded Poland. Radzewski, and Zygalski fled to Romania, then to France, continuing their work even as their country fell. Now enter the British. In August 1939, a strange group began arriving at a Victorian mansion called Bletchley Park, about 50 miles northwest of London. The British government had quietly recruited them: mathematicians from Cambridge and Oxford, chess champions, linguists, crossword enthusiasts. Among them was Alan Turing, a 27-year-old Cambridge mathematician with uncombed hair, a stutter, and ideas about computation that were years ahead of their time. Also, Gordon Welchman, a geometry expert who saw patterns in everything. Joan Clark, one of the few female cryptanalysts in senior roles. Dilly Knox, an eccentric classicist who'd been breaking code since World War I. The organization started in 1939 with only around 150 staff, but grew rapidly. By 1945, 75% of the staff were women, many from the Women's Royal Naval Service, the Wrens operating the machinery that would crack German communications daily. The first break came on the 20th of January 1940, when Dilly Knox's team, working with John Jeffreys and Alan Turing, cracked the German Army administrative key they called the Green. But there was a problem. The war had changed everything. When the Poles had first broken Enigma, the cipher settings changed only every few months. Now they changed at least daily, with 150 million possible settings to choose from. And the Germans kept improving the system. They stopped repeating message keys, a weakness the Poles had exploited. The German Navy used even more complex procedures with a 4th rotor. The Polish Bombe couldn't handle these changes. The British needed something more powerful. This is where Turing's genius emerged. He took the Polish concept and reimagined it. The British bombe, inspired by the Polish Bombe but fundamentally redesigned, became a room-sized electromechanical marvel. Here's how it worked. The bombe didn't try to decrypt messages directly. Instead, it looked for contradictions. Remember Enigma's fatal flaw? No letter could ever encrypt to itself. If you pressed A, it could never light up A. Turing realized this created chains of logical implications. If the codebreakers could guess a word that appeared in the message, what they called a crib, they could test whether their guess was consistent with Enigma's wiring at various rotor positions. Most positions would create contradictions immediately, like saying A equals B and B equals A and C equals A all at once, which is logically impossible. The bombe would reject those instantly. Only settings that survived all logical tests were worth investigating further. Gordon Welchman proposed adding a diagonal board that exploited the reciprocal nature of the plugboard connections. If A plugged to N, then N plugged to A. This enhancement dramatically reduced false positives. By 1940, multiple bombs were running at Bletchley Park. Each weighed about a ton and sounded like a factory of typewriters and knitting machines working simultaneously. They could test thousands of settings per hour. But, and this is crucial, the bombs weren't computers. They were logical deduction machines that required constant human insight. Someone had to choose the right cribs. Someone had to interpret results. Someone had to adapt when the Germans changed procedures. When Germany invaded Denmark and Norway in April 1940, Bletchley cracked the Enigma yellow cipher. Within a week, the decrypts told them virtually every detail of German movements. But there were so many messages and so many unfamiliar code names and German units that the intelligence section was overwhelmed. No system existed to securely distribute such sensitive information. So, despite breaking the code, the intelligence couldn't be used during the Norwegian campaign. They had to learn not just how to break codes, but how to use intelligence without revealing they'd broken the codes. The real brilliance wasn't just mathematical, it was psychological. The codebreakers learned to think like German radio operators. They knew humans got lazy, followed routines, made mistakes. Stuart Milner Barry set up a special crib room in Hut 8, maintaining detailed indexes of previous messages, every person, every ship, every unit, every technical term, every repeated German phrase. This massive database helped them predict what words might appear where. Some German operators used predictable patterns. One operator started every message the same way the British nicknamed him Herring because he kept giving them fish. His messages became instant cribs. Weather reports were gold. German weather stations would transmit Wettervorhersage, weather forecast at predictable times, often including the word weather spelled out. The British even engaged in gardening, deliberately provoking specific German responses. The RAF would mine a particular harbor. German Naval Command would predictably send a message warning about mines in that location, using the place name the British already knew, Instant Crib. And there was Dilly Knox, the eccentric who worked on breaking the Italian naval Enigma. Legend has it he would sit in his bathtub contemplating cipher problems, then emerge dripping with solutions. By mid-1941, after the British captured the German trawler Krebs with Enigma machines and codebooks, Bletchley could discover where U-boats were hunting in the Atlantic and direct Allied ships away from danger. But the German Navy, suspicious their codes were compromised, introduced a fourth rotor in 1942, multiplying possible settings by 26. The British finally broke this shark code in December 1942. The most brilliant part? Restraint. The Allies couldn't act on every piece of intelligence. If British ships avoided every U-boat ambush, the Germans would realize Enigma was broken and switch systems. So they carefully rationed their knowledge, sometimes allowing ships to be attacked rather than reveal their secret. Churchill reportedly called the Bletchley team the geese that laid the golden eggs and never cackled. And they didn't. Every employee, eventually 10,000 of them, signed the Official Secrets Act. Not one broke the silence. The full story remained classified until the mid-1970s. So, what's the final accounting? Experts have suggested that breaking Enigma may have shortened World War II by as much as 2 years. 2 years, millions of lives saved. But the legacy runs deeper than that. This wasn't a story of one genius. It was a relay race of brilliance. Polish mathematicians Ruzicki, and Zagalski broke Enigma in 1932 and worked for 7 years to stay ahead of German improvements. When their country fell, they handed everything to the Allies. Turing, Welchman, Knox, Clark, and thousands of others at Bletchley Park took that foundation and built something unprecedented. combining mathematics, engineering, psychology, and human intuition into an intelligence operation that helped win the war. Tragically, Różycki died in 1942 when his ship sank in the Mediterranean. Rejewski and Zagalski survived but worked in obscurity during Poland's communist era. For decades, the world credited only the British, particularly Turing. Only in recent years has the Polish contribution received proper recognition. In 2002, Bletchley Park installed a memorial to the three Polish mathematicians. In 2014, they received an IEEE Milestone Award for achievements that changed the world. The lesson here transcends cryptography. The Germans built Enigma on mathematical complexity. They assumed bigger numbers meant unbreakable security, 159 quintillion possibilities. They were wrong because they forgot that humans operate the machines, and where there are humans, there are patterns, routines, mistakes, predictability. The codebreakers won because they combined abstract mathematics with understanding human nature. They built tools that amplified human intelligence without replacing it. They collaborated across borders and disciplines. They proved that impossible problems don't require impossible solutions. They require different thinking. Turing's work at Bletchley led directly to his foundational theories of computation. The questions he asked while breaking Enigma, "Can a machine think? What is computation?" became the basis of computer science itself. Today, your phone uses encryption far more sophisticated than Enigma, but the fundamental principle remains. Every code is created, implemented, and used by humans. And where there are humans, there are insights waiting to be found. The mathematicians who broke Enigma, Polish and British, men and women, professors and teenagers, weren't superhuman. They were people who learned to see patterns others missed, to question what seemed impossible, and to persist when everything was at stake. So, when you face your own impossible problem, remember the three Polish mathematicians working in Warsaw in 1932. Remember Turing working at Bletchley in 1940. Remember the thousands of Wrens operating the bombs. Remember that. The solution might not be more computing power or more time. It might be seeing the weakness in the strength, noticing what everyone else ignored, combining different ways of thinking. This has been Chishel. If this story changed how you see problem solving, hit that like button, subscribe for more deep dives into the moments that shaped history, and drop a comment. What's an impossible problem you think could be solved if we just looked at it differently? Until next time, keep questioning everything.